Hello everyone. In this video, we're going to go over the quiz portion of test 2. In general, everybody did really well on the test. The average was roughly 90%, which I think is really good. Not exactly sure for the reason that you might all be geniuses. It might have something to do with the different format with the online testing. In any case, it's good. I'm happy with the results. I hope you are too. So in the quiz, there's only one question where a significant percentage of you got it wrong. There were definitely a few other questions where one or two of you missed it here or there, but this problem here that you see right now is the one that a pretty significant portion of the class, possibly half, got wrong. So that question is, which of the statements about room modes below are false? There are 4 options. Cumulative mode count increases as a square frequency. So down lower here we see the answer is the third one. That's the one that is not true about room modes. So the cumulative mode count increases as a square frequency. The primary concern is isolated clusters of modes, and adding a closet can be a practical solution to poor modal distributions. But modes only occur at lower frequencies in small rooms. That one is not true. Just to show you why on each of them, maybe you'll remember this slide, but this one shows that the cumulative mode count does increase as a square frequency. So here our x-axis is frequency, and you see as we go to higher frequencies, our number of modes is increasing as a square of that frequency. This one, so it says primary concern is isolated clusters of modes. That one is true. Here, so using this mode calculator, the reds are the most problematic. You see we have 2 modes that are exactly the same frequency, and they're separated by quite a bit, 15 hertz, which is quite a bit when you're down at 35 hertz. It's half an octave. So you have this cluster of 2 of them right next to each other, and then you have a pretty decent gap. And you have another gap of 20 hertz, and you have 3 of them that are right next to each other. So those isolated clusters, those are most problematic. That was something we covered in lecture. That's what the bolt area and other methods try to avoid. So this is the one that was false. It says modes only occur at lower frequencies in smaller rooms. Maybe this is a little tricky. Maybe that's why a large percent of you got this one wrong. But the reason why this one is false is that modes are primarily problematic at lower frequencies in smaller rooms, but they occur much more broadly than this. So modes are occurring at all frequencies in rooms of all sizes. They occur in everything. Like we saw the Chladni plates or the string. Vibration modes are all around us. They occur at all frequencies, all different sizes of rooms. It's just that they're more problematic at lower frequencies in smaller rooms if you don't get the room dimension ratios right. So that's why that one's false. And then this one, probably remember that adding a closet can be a practical solution to poor modal distributions. We have 2 different rooms here. One is the room before the closet was built. It has really bad room dimension ratios. They're all multiples of 4. And you see we have some problematic clusters of modes, isolated clusters. But if that closet is put in, it changes the depth of the room from 16 feet to 13 feet, then we no longer have the ratio of or we no longer have the dimensions being multiples of 4 feet in all dimensions. So it really helps. It puts us all into the green. So this one's true. That's it for the theoretical question part of it. I'm going to do another video for the problem. That'll be next.